thank you for coming. Moyed, Shreyas, and I will be taking you through this paper writing workshop this semester, and we'll be covering everything you need to know to write a good technical paper. This will be helpful for you because you will be submitting a project report at the end of the semester, but this also extends beyond your project report in terms of any technical paper you might want to write uh, during or after your academic careers. So, yep, let's get started. So, a quick overview of the content of the workshop here. We will be covering the purpose of writing a paper. So, why do we write papers in the first place? The types of paper writing. So, there are a couple of formats we need to know before we write a paper. Identifying who your audience is, which is also very important. Defining your problem statement, anatomy of a research paper, which is the crux of the material here, and other important pieces of a research paper. So, yep, let's dive into it. So, why do we write papers? Basically, to report on some experiments, summarizing the findings that contribute to a new body of knowledge, or aggregating information about some historical work that's been done within a body of knowledge or within some specific subdomain. So, if you're going to be writing a paper, it's helpful to know of the tools that you need to be writing a good paper. So, we use text editors to write a paper, and a lot of people use Microsoft Word because it's easier to use. But if you're going to be writing a good academic paper, you should definitely learn tools like LaTeX because that's the required format for a lot of the conferences. Um, you should also look into reference tools like Mendeley and Zotero. If you're using any information, any code that's not your own, it's very important to cite that, otherwise, it could be flagged as plagiarism. And apart from being technically correct, you should also write material that's grammatically correct. So, do use tools like Grammarly. So, types of paper writing. There could be many kinds of paper writings, but the two main ones that you would encounter are school papers and conference papers. So, school papers are something of the sort like you write a report on some experiment you did as part of your coursework. It could be like a 1 or 2 page report. Um, Conference or workshop papers, on the other hand, are more extensive pieces of research or research proposals. I guess you guys recently submitted your project proposals. So, one of the goals of the project in this course is to produce work that's as close as possible to something that's publishable. So, not only want you to write we not only want you to do good work, but we also want you to learn how to write a good publishable paper. So the report that you write for the project has to be as close as it can be to a publishable research paper. There are a couple of conferences, and each of the conferences have their own format of paper that they accept, but notably the three main ones are NeurIPS format, the ICML format, and the ICLR format. Um, for this course and the course project, we will ask you to stick to the NeurIPS format, but the there are minor to major differences between these three formats. The NeurIPS is a single column format. The ICML is a 2 column format, and the ICLR is also kind of similar to the NeurIPS format. But for this course and the course project, we ask you to stick to the NeurIPS format. So some other expectations from your ideal project report, apart from sticking to the NeuroIPS format, are you should structure your report or paper in accordance with the anatomy we describe in this workshop. You should include links to your code repositories or code notebooks, um, and you should also include references or citations to any papers that you've referred or any code that you've used. So if you've used some code that you have not written yourself, it's important to cite that. Otherwise, it could be flagged as plagiarism. Other thing is, you should definitely reference and include licenses to the data set that you've used for the project. So most of the times you will not create the data sets that you're using for your project, so it's also very important to include the license for the data set. So before you start writing your paper, it's very important to know who your audience is. And why I say that is because oftentimes you will be applying deep learning techniques to a different domain, and you might be presenting your paper in a conference that has audience that might not be as technically inclined in terms of deep learning as you are. So it helps you tailor your the content of your paper towards the audience. Um, so for example, if you apply a deep learning technique in the field of medicine and you're presenting your paper in a medical conference, then rather than going into the details of your model description, your model architecture, um, you should talk more about what technology you have used and how it is different from something that's generally used in the field. And you should talk more about how the technology that you have used can bring about an impact in the field. But if you're submitting your paper, for instance, to a computer vision journal or conference, then you can be pretty confident that a lot of the people in the conference have enough knowledge about deep learning, and then it makes more sense to talk more about your model architecture, model description, or other technical details. So who should your audience be? Your audience should be people with similar background as you, or people who are in the domain that you have applied deep learning to. And they should be the people who can reproduce your work, provided you provide appropriate details in your methodology. So, what I mean by that is you should be as honest as possible in depicting your results, so that people who go through your paper and try to re implement what you have done get similar or as close to as possible results as you have done. So next up, let's talk about problem statement definition. So whenever you're conducting a research, you're usually trying to solve a problem. So you should be able to define your problem statement clearly in your research paper, and the problem that you're proposing to solve or the methodology that you're proposing to solve the problem must have a element of novelty. If you're just reproducing something that's already been done, that's not research, and that's a reproducibility project at best. So it must also be feasible. So the methodology that you propose must be able to, in some sense, give a solution to the problem that you're trying to solve. And the methods that you use should also be ethical. So should not it should not harm anyone or anything, and should be approved by a designated ethics board. So now to the anatomy of a technical paper. These are the sections that you would find in most of the technical papers, especially the ones mentioned just now, the NeuraEPS, the ICML, and the ICLR. Um, so you usually start with an abstract, and an abstract is the shortest section of your research paper. It should not be more than 150 words. Um, an abstract is what makes or breaks your paper. It's basically you pitching your research to anyone who's reading your research paper. It's like an executive summary of everything you've um, done till the point of publishing your research paper. So, when you're doing research, you're proposing a new solution to a problem. So it states the problem statement, and then you quickly move on to describing your methodology and the contributions that you have made that provide an answer to the research question. And then you also briefly describe how you've tested the methodology that you've proposed and what impact this research will have and how it compares to the previous work that's been done in this field. You should also mention all the keywords in the abstract, because most of the time when people are looking for research papers or answers to problems in research papers, they usually just go through the abstract and look for keywords that might relate to the problem that they're looking to solve. So it's super important to have all the keywords, important keywords in the abstract. So I've just described what an abstract is. Let's look at a couple of examples and see how actually an abstract is written. So this is an example of a reinforcement learning paper, and I've highlighted two sections of the abstract. The first section of the abstract um, highlights the research question or the research problem that they're trying to solve, and the second section of the second highlight section um, talks about the specific contribution they've made in terms of answering the research question. So, if you don't do anything else in your abstract, you should at least have the problem statement or the research question and the specific contribution that you're making towards solving that research question. So this is another example of good abstract. This is a paper by DeepMind, and we can see that I've highlighted three sections of the paper. The first section, in the first couple of lines, they talk about the researcher's contribution towards answering a problem. So they state that they're basically using CNNs to train a particular variant of Q-learning to train an agent to learn a control policy for playing Atari games. And the section 2 talks about how the research was tested. So they uh, applied this agent and let it play Atari games, about 2600 games. And then section 3 talks about the impact of the research. So again, if you just read this abstract, you will immediately know um, if this paper relates to something you are, or the knowledge that you are looking for. So if you want to keep reading this paper, or if you just want to drop it because it doesn't have the knowledge that you're looking for.
After the abstract, you have the introduction section. We saw that the abstract is an executive summary for the work you've done or the contributions you've made towards answering the research question. But the introduction, on the other hand, dives deeper. It sets a tone for the research work by explaining what the actual problem is, starting from the solutions that already exist and their limitations. Then you segue into explaining what you are contributing to this research. So if you have a handful of already existing solutions, say X, Y, and Z, you briefly describe them and their limitations. And this way, you're providing context to your research problem and stating why it's important. So a few tips for writing a great introduction would be to summarize the current understanding of your research project, that is, explaining what work has been done on your subject topic till date. Then you state the purpose of your research project and briefly describe the kind of questions your research would be answering. These questions could be based on the limitations of pre-existing solutions that you've specified, and you need to mention that your research aims to answer some or all of these questions. Towards the end of your introduction, you have to briefly explain the methodology that you're going to use in your paper and what you expect your results to look like. Bear in mind that your results at the end of the paper may or may not be the same as the expected results. And in the end, you'll summarize the structure of the remainder of the paper, saying that you'll be going deeper into the literature review, description of your model, and dissecting different results that you got. So as I mentioned in the introduction, you need to talk about what the research problem is and what solutions already exist. There's a section for specifying these things in detail called related work. Some people call it literature review or background. There's no set title for the different sections of your paper except the abstract, introduction, and conclusion. So in this section, you're going to go deep into the related work or techniques that have already been used in this area of research. If you're trying to bring in a new solution, you will talk about whether there's an existing solution that relates in some way to your solution. And when you're talking about historical works, depending on the field, there could be multiple research papers or multiple solutions in that field already. You will have to summarize as well as categorize these previous works and present them in an organized way. For example, if you have 4 papers from 4 different people, say A, B, C, and D, and person A and B are using a deep learning approach to solve this problem, while C and D are using classical ML techniques to solve this problem, then you'll put A and B in one group and C and D in the other. You want to group them based on approach rather than talking about them separately. It makes more sense that way. So we've kind of mentioned this already, but the main components of literature review would be to discuss the subject matter under consideration. And like I said, if you have multiple works that share the same theme or approach, you put them in the same group. Then you'll talk about similarities of these approaches and their differences. And in the end, you'll briefly mention what you will be bringing that is new to this area of research. Next up is the methodology section. So now you've set a very good tone for your paper. You've given a good introduction and talked about the related work as well. In the methodology section, things start to get a little more technical. In this section, you'll be describing the general approach to performing your experiments, and you'll do this in a way such that your results are easily reproducible. Now let's discuss some the components of the methodology section. The first component of this section is the model description. You'll have to start with a brief description of your model, that is specifying that you're using RNNs with attention mechanism or CNNs or something else. Then you will clearly describe your model architecture. After the model architecture, you will talk about the objective function being used in your system and how your model will help solve that objective. The objective can be to minimize a loss function or maximize a reward function. Try to present most of the model description with correct mathematical expressions, including the expressions for loss function or reward function. The next component of the methodology section is dataset description. So you want to talk a little bit about the data you're working with. You'll have to specify the type of the data. That could be speech, image, video, or 3D point clouds, and so on. And then you also want to talk about the kind of mode you're working with. That is, if the data mode is single mode or multimodal. Then you have to specify how the data set was collected. And if there's any form of pre-processing that was done on the collected data. And it's okay if you haven't collected the data yourself or performed pre-processing on it. In such a case, you can just mention the source of the data. Also, if you're generating synthetic data because you didn't have enough data, then you'll have to specify that as well. In the end, you'll have to specify, you'll have to mention simple properties of the dataset, that is its size and how you're splitting the data into test, validation, and train sets. For example, if your split is 80 to 20 or 60 to 40, you'll have to explain why you're doing it. The next component of the methodology section involves discussing the baseline and evaluation metrics. The baseline is a solution that exists already. You need to make sure that you're selecting a comparative state-of-the-art baseline. You'll have to specify if you're implementing the baseline from scratch or if there's a pre-trained model that you can import into your code. If it's the latter, then you'll have to properly reference the baseline. Another important part of this component are the evaluation metrics that will be used to compare the results with compare your results with that of the baseline. Evaluation metrics vary from project to project. You have to specify the mathematical expression for the metric if it has one, and explain why you're using this metric.
Hello everyone, I'm Muayyad and I'll be taking you through the last parts of this recitation where we will be talking about the experiment result and discussion, the conclusion, and some extra points on how do you make your paper generally better. So the first point is about experiments. So generally when you're reporting your experiments for a machine learning related paper or any paper in general, you would want to keep all the experiment details in your reporting. So you want to include some of the hyperparameters that you took, some of the meta information about the models that you trained, and also information about the dataset that you used, and any other settings. You include the settings because you would want to always compare your work to other people's work, because the general idea behind writing a paper is you're trying to argue that your work is better in this specific task than the other papers available online. So what you need to do is also you need to try and keep your experiment settings the same, or if you have a different setting for a specific model, you'd also need to include that, because sometimes adding some extra, for example, pre-processing for a dataset can improve the model significantly. So you want to make sure that you include everything, the setting, the experiments, and the comparison between your work and other people's work. Another part of the experiments is the ablations, and we were very clear that this is a major part that you need to include in your homeworks as well as when you're writing your paper for this project and further on. The idea here is that you would want to see the effects of each and every component changing in your model, how they change, and this is an extra part. It might be more than the method, the general method that you use. You might want to see the effect of each and every single component. So if you look at the paper on the left, you can see that the subpillar component was added to a baseline model that provided like a 2.08 improvement, and then adding the PE on top of that, add an extra improvement, and so on. So we'd want to see what each component improves your model so that you can go back and try and improve it more, not just by randomly adding more components, but then checking how each component provides you with extra computational extra work. Another point that you want to look into is the interaction between the different components or the different hyperparameters. So in some areas, adding two components together might be worse than adding them individually, or adding two components individually might give you a worse result than combining them together. Because if you see on the left, when we add when you increase the training epochs, it might be better to do this without adding learning rate decay, but this might not be the case, because when you add more training epochs, this gives us a bad result. The same thing is when we add dropout individually, that might increase our performance, but when we include it with other regularization techniques, that can lead to worse performance in the paper that you see on the left. So the discussion part of the paper does not need to be a separate section. You would want to include this when you're talking about your result. And here, generally, you would want to discuss the results and provide some insight into them, the general ideas that you took, the takeaways, and whatever you were able to find from your result and ablation. You should combine them together. The final part that you want to include in your paper while writing it is conclusion. This is basically a summary of the report or of the paper. It basically comes at the end of the paper, and you would want to do two things. You would want to reiterate everything that you mentioned before. You'd want to talk about the questions again, and you also want to mention your argument one more time. And you also need to include the possible shortcomings, the possible areas that you might improve your work. So here, this will improve your number of citations or the number of people that work based on your paper, because you show that you understand the topic, and you see where your shortcomings were, and if given the time, the computer, or any other type of resources, you would work on improving your model using this, which in our case for the project will give you extra credit. And the other thing is including extra research questions will make people, or will motivate them to work building on your work and to start trying to answer these questions if they're valid questions. The last part is the references. So this is an integral part. You should reference everything that you take from someone or somewhere. This is, for the most part, is going to be in the research review part, and you should follow the referencing style that the paper that you're applying or the conference that you're applying to wants it. For our case, you need to follow the New York's paper referencing style. So now we need to talk about some meta ideas about your paper. The first one is reproducibility. So when you finish writing your paper, you would want a person that's familiar with the field to be able to reproduce the exact same result that you got without needing to look into anything else. Why? Because this will make people build on your work more. If they can reproduce your work, then that means that they can either use some of the open research questions that you introduced in the conclusion, or B, use your work, some of the components that you introduced as part of their work, because they were able to reuse them. If you can't reproduce your paper, you might want to add some extra information about your parameters, or either inside the paper if you have the space, or you can add some supplementary material, or you would want to add and reduce the code for your paper, which will make people more likely to reuse it. If your paper isn't reproducible, you will get emails. The issue with getting emails from people is that for each person that gives you or like the emails you about your work, there are 5 or 6 other potential people that might have worked based on it that did not email you. And this means that for number 2, your paper either won't get cited, or it will get cited way less, by only the people that were like emailed you and you were able to communicate with them. And the last thing is, which is even worse, is that people might question the validity of your results by when they re-implement your work, and then they report in their own work that this paper like we were not able to reproduce the results that were shown in this paper. So you'd want to make sure that you include everything that is needed to reproduce your paper, whether it's experimental settings, hyperparameters, or any other metrics or setting that's needed to rerun your experiments. Another thing relating to reproducibility is related mostly to RL, but it also applies to some of the field that you're working on in deep learning. So in reinforcement learning, because of the structure of the field, which is more random, you might stumble with a bad policy on a good starting state and reach the goal. This is like the miracle experiment, and then people might report only that. And then when people try to reproduce the same work, they're not able to, because this is a very random experiment that's not like the true representation of their work. So what people do is you would want to use a specific seed for your experiments, and make sure you report that seed, because people then can reduce some of the randomness that goes into machine learning in general. And also we would want to present your results as terms of averaging of multiple runs. So if you see the hue around this experiment or this reported experiment, this resembles, or this puts that this is the variation from the median result that you reported, and normally your results should fall into this hue, this range. Another point of interest that you want to consider when you're writing your paper is that you want to keep a good story or narrative throughout the paper. So basically, you would want to your paper to be focused on a single or multiple research questions that you look into in the previous work. You would want to put people's focus on that, and then either like you want to focus on a theoretical idea, or you want to see a separate field or a separate setting that previous work fails to give good results in. This may basically mean some low resource formulations or some certain classes of the word that other models fail in. So if you make sure that you provide these and then you guide your audience through your work on how you think your work will affect them, this will provide some aha moments later on when you provide your results or even when you provide a new interesting idea, which is the guideline. Basically, this is you trying to prove that your argument is true and you're trying to make a story that supports it. So again, the research paper is an argument why your work is better. So you need to make sure that you convince the reader that your work is better than the other work available in the field or in the setting. Some general points: try to make your work or your words less technical, and try not to introduce new technical terms. What I mean by less technical is that you don't want to introduce some extra hard technical ideas that are only used in your paper. So, for example, if you say that we extract complementary semantics via feature entanglement over space and time for a certain video application, this might seem like an interesting thing to say, but at the same time, just saying that given an RGB video, you run the first CNN through the temporal dimensions, and you run another CNN through the spatial dimensions, and then you combine the results. You're basically saying the same thing, but one language is more difficult to understand than another. So this is something that you want to keep in mind. It's related to the readability of your paper and also to the general understanding of it. So now we walk into a paper released in 2018, but it has been recently trending, troubling trends in machine learning scholarships. It shows some of the bad ideas that were seen in most machine learning papers. So one thing is the discussion between explanation and speculation. So this is more apparent in discussion about Adam. So internal covariance shift is something that does not have a theoretical explanation, but there are signs that show that this might be something happening in our setting, and this is what the paper about Adam reported. But the issue is that it was presented not as speculation; it was presented as a fact, which makes that recent research that looked into internal covariance shift and it found that this is not the case. It will make that work weaker. So the idea here is you would want to be sure that you report what is theoretical and it was proven in a theoretical manner, clear, and what you suspect is the result also clear. This does not mean that speculation is bad, but speculation is something that allows people to investigate it more. And if you present something as theory, it's either right or wrong, but speculation allows for more discussion about it. Another thing is the failure to identify the sources of empirical gains. So going back to the idea of ablations, this is why you do ablations. You would want to really see where your model performs best. So you might be reviewing a paper or building on a paper, and you see that the choice of hyperparameters was not good, and then you're trying to improve on that hyperparameter choice. So basically, in some cases, you might find that you can get like 10 points of 10 points of improvement. 8 of them might be of just tuning hyperparameters, and 2 of them might be just you improving the model actually, which is acceptable. But what's not acceptable is that you find that there are 12 points that are achievable by just doing hyperparameter tuning, but then because you mixed hyperparameter tuning with model changes, you're able to only find 10 improvements in your results, which makes that when people come and work on improving your paper, they would find this and they would poke holes at your reasoning for choosing your specific method, because basically your methods were worse than the other methods, and like hyperparameter tuning was the actual culprit for improving the model. And another thing is the use of suggestive definitions. So this relates to the idea that you don't want to use a term that has a specific understanding or a specific definition in a field that's known for most people, and then you try and use it for your own field or for your own application. An example of this might be model curiosity in reinforcement learning, which this refers to the idea that a model is curious when it tries to go and search for states that it has not seen before. Because in basic Q learning, you would want that model learns from what it has seen, so you would want to make the model go and reward the model for trying things out that have never seen before. But when you say something that curiosity, this might include other connotations that are not the same for the model as what we understand about curiosity, which includes not only trying new, like going to places that have never been before, but maybe trying new ideas, new theoretical ideas, which the model definitely does not. It only goes through like it adds randomness to the selection of its states. So generally speaking, is that you want to keep your terms consistent to things that are well defined in your specific field and try not to mix different fields together. So that was it for this paper writing workshop. If you have any questions, just post them on Piazza. And good luck with your writing your work for your project.